Hello, today we're going to be looking at the area and perimeter of parallelograms and trapezoids. So just to start, let's remember that in the previous investigation we talked about rectangles. Rectangles, we know the main formula for a rectangle to find its area was just base times height. The good news is a parallelogram is the same idea. So we would still write down that the area of a parallelogram is the object's base times the object's height. The main difference or feature that I want to point out that's different is that in a parallelogram, we also have this term called slant height. And that is the measure basically of that side measure that is not the one perpendicular to the base. So the height has to be perpendicular to the base as we see straight up and down. So in class I illustrated that if I took a ruler or measuring stick and I measured myself, I could tell people I was 6 feet tall if the measuring stick was slanted. But if I'm actually doing proper height, I know it has to be perpendicular to the ground and go straight up and down. So we would never give slant height as the height of an object. Slant height will be important, however, for perimeter. Since perimeter is the distance around the figure that we need to add up, we would need to consider that there are two slant heights that are equal in a parallelogram, and then there's two bases. So for perimeter, you could, and it's written differently depending on the person, but the main thing you need to understand is you're going to be adding the slant height plus the base plus the slant height plus the base to get the whole outside of that figure. And that could also be 2 times the slant height plus 2 times the base, if you wanted to simplify that formula. So let's try one. In example 1 here it says, find the area and perimeter of the parallelogram. So to begin, I can find the area. We'll go ahead and do area is equal to base times height. So in this case, we see the base is 15. And we see the height, which is straight up and down, perpendicular to the base. We even see the little right angle mark, is 5. So to find this, we would just simply do 15 times 5. So we would get, and don't forget your units. So we would end up getting 75 centimeters squared. Okay, to find perimeter, perimeter is going to be all of those outside measures added up, which we said will include 2 of the slant heights along with 2 of the bases. So in this case, when we're writing it down, you could do 7 plus 15 plus 7 plus 15. Some people find it helpful to go back and write in those missing measures. If you find that helpful, certainly that's perfectly fine. We're going to end up, of course, getting here when we add these up 44. And for perimeter, it would just be centimeters. Okay, now we're going to take a look at one where we have the figures are contained on grid paper or on a coordinate grid. One thing I do want to point out about this first one, and sorry, it got cut off a little bit at the bottom, but if we're finding the area and, the base and the height to find area, and that's all we were asked to find here, by the way. Notice that this figure, it's hard to identify the base because we see that the slanted measure is right here. So what you can do instead is almost turn your paper onto its side and make this dimension here the base. So we would get 1, 2, 3, 4, 5, 6 as the base. And then the height, we want to do perpendicular to that. So we could go straight across like this and count 1, 2, 3, 4, 5. And so the area of this object, since it's base times height, would just be 6 times 5, or 30 square units. For the other object over here, it's a little bit easier to find the base. On this parallelogram, we can see the base is 1, 2, 3, 4, 5. And remember, it's just the line distance. So some people have said to me, well, this is a partial block. I'm not worried about the block. I'm looking at the length of the line. Since it's that whole grid line, it counts as a full block. So 5 would be your base, and then your height is straight up and down. So 1, 2, 3, 4. And so for this one, because area again is base times height, we would have 5 times 4, which is 20 square units. So that is the gist of parallelograms. Now we're going to take a look at trapezoids. So trapezoids, if you recall, are still quadrilaterals, but this time they only have one pair of parallel sides instead of two. So their formula is completely different, but it actually can be found by using the area of a parallelogram. So if we can recall that the area of a parallelogram is base times height, which we just did, then we can actually transform a trapezoid into a parallelogram by cutting it in half horizontally. So what you can see here is, imagine that a cut took place right here, okay? It was cut, and then along that line, and then the two pieces were reassembled, but this whole piece flipped over. And so now we have base 1 down here up against base 2, and we can see that we have cut the height in half, but this makes a parallelogram. Because parallelograms area, or the base times the height, we can see that this whole base would be base 1 plus base 2. It's just the sum of those. And we can see the height of the parallelogram in relation to the trapezoid is just half of the original height. And so the formula for a trapezoid ends up just being the base of that parallelogram, which we call base 1 plus base 2, multiplied by half the height. This is not the only way to write this formula, certainly, but in the connection to the parallelogram, it's probably the best way. So let's try to use that in the next couple of problems here. So in example 3, we are asked to find the area and perimeter of these trapezoids. Here, I'll leave the formula up at the top so we can see. So perimeter, we don't have to write a formula, we just know that's all of the sides. But for area, we want to reference that formula that we just did. So area is equal to base 1 plus base 2 times half the height. So for this one, base 1, and it doesn't actually matter which one you call base 1 or base 2. We're going to go ahead and call base 1 6 and base 2 8. And then we're going to do times half of the height, so times half of 4. So it's important to recognize that the bases are being added first, so that's why they're in the parentheses. So we would end up with 14 times half of 4, which is 2, and that would give us 28 square units, since we are not sure what unit this is. Perimeter, on the other hand, would just be the outside measures added up. So the perimeter would be equal to 6 plus 7 plus 8 plus 5 which would end up being 26 units. Okay? On this next one, the figure looks a tiny bit different, but the approach is still the same. So area, again, is going to be base 1 plus base 2 times half of the height. In this case, you can see the bigger base is on top and the smaller is on bottom. Again, it doesn't matter. So we'll just simply put in base 1 as the 9 inches plus the 7 on the bottom. And then the height, this is important. Don't accidentally pick the slant height. See how that's clearly not going to be the height of the figure, the 7. The height of the figure has to be perpendicular to the two bases, and we can see these right angles. So that tells us that it's going to be 5. So then we would end up adding the 9 and the 7, and we would get 16. And we're multiplying that by half of 5, which is 2.5. And so then when we do 16 times 2.5, we end up getting 40. So this would be equal to 40 square inches for your area. For your perimeter, you're going to add up all the outside measures. So we have 9 plus 7 plus 7 plus 5. And that ends up giving us 28 inches for our perimeter. And that's it.